In this video, I'm going to approximate the area under a function. So the function in our case is 1 over x, which is this function, and we are going to approximate it from point A to point B, which is from this point to this point. We are going to approximate it by dividing the area under the function or under the curve into smaller rectangles. Okay, we are going to divide it into smaller rectangles, and then we are going to find the areas of each of these rectangles and then add them up. So that's how we are going to do the approximation. So let's go ahead and start off with something called left sum. As you probably know, in our case I have 4 rectangles, so I'm going to just call it 4. Okay, so the rectangles are going to be like this. The first one, so the second one, third one, and the fourth one. So when I find the left sum, what I do, these intervals, so these divisions, by the way, these are each delta x. So they are each delta x. Width is the same. It doesn't change, delta x. But height will change depending on whether I consider left sum or the right sum. The left sum, when I consider it, I'm considering the left side of the rectangle as my height. Okay, and coming up, right sum, when I would consider the right side of the rectangle as the height, but the base doesn't change. So let's find the left sum first. Okay, for this function, this is how it's gonna work out. So this height, which is gonna be, let's say my A is 1 for simplicity and B is 2, okay? Even though the diagram kind of looks a little bit off, but don't worry about that. A is 1 and B is 2. So at this point, so area of the first rectangle is gonna be width, which is delta x, times height. Height is gonna be the value right here. So let's call this x sub 0. Okay, this is x sub 0, this is x sub 1, this point is x sub 2, this is x sub 3, and this is x sub 4. Okay, so this is gonna be height is gonna be f of x sub 0, which is, by the way, nothing but 1 over 1, which is just 1. So the first one is going to be f of x. Let me write it out, actually, it will help. F of x sub 0 delta x plus f of x sub 1 delta x plus f of x sub 2 delta x plus f of x sub 3 delta x. Remember, I'm considering the left side, okay? Left side of the first rectangle as the height. So x sub 0, I got 1, right? So my L4 is gonna be 1 times, okay, 1 times delta x. Delta x, so from A to B, I have 1 unit, right? So B minus A divided by n, number of rectangles I want, okay? So there's gonna be b minus a is 2 minus 1 divided by 4, so it's gonna be 1 over 4, that is 0.25. So each of my delta x's, so each of these delta x's is 0.25, so times 0.25. Now for the second rectangle, this side is gonna be the left side, which is gonna be f of x sub 1. So now here you have to remember, at this point my x value is 1.25, so it's gonna be 1 over 1.25 times delta x, which is 0.25. For the next one, which is gonna have left side of the rectangle, which is at 1.5, so it's going to be 1 over 1.5 times 0.25. Okay, and the last rectangle, the left side is going to be this one, and at this point the coordinate is 1.75 x coordinate, so it's going to be 1 over 1.75 times 0.25. If I simplify all these numbers, by the way, I get L sub 4, okay, is gonna be 0.7595, and I rounded it here, a fourth digit after the decimal. So left sum is 0.7595. Now, by looking at the diagram, you can see when we find the left sum, we are in essence finding the area of the rectangles that goes above the curve, above the function y is equal to 1 over x. So we are overestimating here. Overestimating. Now we are going to do right sum, R. So R sub 4. This time, instead of considering the left side of the rectangle as height, we are going to consider the right side of the rectangle for the height, okay, for each of these rectangles. So if you start off with the first one as right, then you're going to be continuously doing it correctly. So for the first, so now the triangles are going to look like, rectangles are going to look like this, and this, okay? So let's find the first one area. My delta x doesn't change, but what changes? My height. So that's going to be at x1 as opposed to being starting at x0. So it's going to be f of x1 delta x plus f of x2 delta x plus f of x3 x sub 3 delta x plus f of x sub 4 delta x, all of this. Now we are going to just plug in these numbers. R4 is equal to f of x1. So now at x1, the x coordinate is 1 plus 0.25, which is 1.25. It's going to be 1 over 1.25 times 0.25 plus 1 over 1.5 times 0.25 plus 1 over 1.75 times 0.25 plus 1 over 2. The last one is going to be this side. And 1 over 2 times 0.25. If I do this calculation, I get right sum to be 0.6345, and also I rounded it to the fourth digit after the decimal. So that's how you find left sum and right sum. But look, for the right sum, if you look at the green rectangles, okay, you are actually underestimating. So here you are underestimating. So underestimating the area under the 1 over x curve. So the truth or the ground truth or the actual area under the 1 over x curve between 1 and 2, x equal to 1 and 2, should be somewhere between. So let's say my actual area is A, then it should be somewhere between 0.6345 and the other number that we got, 0.7595. That, by the way, should lead to something else, so which is called midpoint rule. So midpoint rule. So what you do, instead of using one of the sides, that means for each of these rectangles, we used either the left side as the height or the right side as the height of the rectangle. Now, to get a better approximation, we are gonna just do the middle, take the middle of each of these delta x's. So this middle, and this middle. And we will find or evaluate the value of the function right at the middle. As you can see, that probably would give us a rectangle like this, okay? And that would probably be a better approximation. So again, see, you can see the red rectangles. And the last one here. Okay, so we are going to find the sum using the midpoint. The sum becomes this value. Again, I rounded it to the fourth digit after decimal is 0.6912. Now, what are these midpoints, by the way? So the midpoints, the way you find it, you take this point and take this point, okay? And then add them up and divide it by 2. So this midpoint is 1.125 and this midpoint is 1.375 and this midpoint is 1.625 and this midpoint is 1.875. Just for example, the last point is 2 and this point is 1.75. So if you add 1.75 with 2 and divide it by 2, you're gonna get 1.875. And for this left side, as an example, starting point is at 1 and the ending point of the original delta x, first delta x, is at 1.25. Okay, add them up, divided by 2, you're going to get 1.125. And you can figure out the midpoints for each of these delta x's. So I just apply the formula, which is f of x delta x. So for the first one, I get this, second one, third one, and fourth one. And if I simplify it, this is what I get. And please note that this number is actually between this number and this number as expected. So midpoint gives you a better approximation. Now, there is no rule that says that you have to use the left point of the delta x or the right point of the delta x or the midpoint of the delta x. You could use any point, as a matter of fact, okay, any point within that window. So if this is your delta x, so it's getting a little bit crowded here. Let me see if I can use another color. So let's see, consider this one, okay, this delta x. You could pick the left, you could pick the right, or you could pick anything in between, okay? If you pick anything in between, then, by the way, what you have is this scenario. Initially, we have had the formula I is equal to 1 to n f of x I delta x. Now, our assumption was that we are considering either left or the right, okay? Then if you use the middle, this formula changes a little bit. You use a bar, okay? If you use the middle. But what if you don't use the middle? You use any arbitrary point, then we put a star on it, okay? Star like this. So you could pick any point within that delta x window for each of these rectangles. If your point could be any arbitrary point within that window, then this sum, by the way, is called Riemann sum, okay? Riemann sum, R-I-E-M-A-N, and Riemann sum. It's named after a German mathematician. I think his name is Bernhard Riemann, I guess. Yeah. So it's a famous sum in mathematics. It's called Riemann sum. So what did we do? We took a simple function, okay, 1 over x, and we tried to approximate the area under this function under this function and above x-axis. Of course, you know that, right? Area under this function and above x-axis between a is equal to 1 and b is equal to 2. We did that by using the left sum, by considering the left side of the rectangle as the height, and the width is delta x for every one of them, and we got this number. And we found the right sum by considering the right side of the rectangle as the height, and we got this value. And then we went ahead and used the middle of the rectangle, okay, which is the midpoint rule, middle of the rectangle, and approximated that function, and this is what we got, okay. The left estimate or left sum was overestimating the area under this function, whereas the right sum was underestimating area under the curve, and midpoint gives you approximately close to a decent approximation of the area under the curve or area under the function. And then we talked about Riemann sum, which is basically happens when you take any point, okay? It doesn't have to be left, right, or the middle. It could be any point within that window. Then the sum we get is called the Riemann sum. And as you know, we probably will take this summation and apply limit to it and goes towards infinity, then this delta x has become extremely small. So in the limiting case, we are going to go ahead and find the exact area of this function under the exact area under this function 1 over x between 1 and 2. I hope that this discussion was helpful. Thank you very much.